Hello, what's up everyone? Welcome to this live stream called Learning UIKit when you already know SwiftUI. So I think this topic was the one that was the most requested over the past year. So I'm quite excited to finally be doing it in a live stream. And so what's the goal for this live stream? Who is this live stream for? If you've picked up iOS programming a couple years ago and you've mostly worked on projects that were fully in SwiftUI and you've never really had a chance to use UIKit, and maybe you would like to know the basis of UIKit, this live stream is definitely for you. I'm not going to try and teach you UIKit in depth during this live stream. First, because it would be way too long, but also because UIKit has been there for almost 2 decades now, close to 2 decades. It was first released in 2008, so 28, so 16 years, 16 years. Between now and its release. And so over these 16 years, there has been so much content that was put out there, whether it was by Apple, by the iOS community. So whenever you want to learn a UIKit topic in depth, you have the resources that you need. However, what might be missing is knowing the general structure of a UIKit project, knowing what the equivalent of the main SwiftUI concepts in the UIKit world. To say it otherwise, in order to let me rephrase it. What I wanted to say is that in order to be proficient in a topic, you need to know what you don't know. So meaning that you need to have pointers to different things, and you know that you don't know these things in depth, but the day you need to learn them in depth, you know where to look. So that's my goal with this live stream, to give you pointers, to give you an idea of what's the general structure of a UIKit project. So for this, we are going to implement a basic UIKit app, and we're going to do it from scratch. And I will try as much as possible to make parallels between what we see in a UIKit project and what we see in a SwiftUI project. This way, if you know SwiftUI very well, it should help you pick up on the basis of UIKit also quite fast. Finally, if you are watching live, don't forget that there is a chat. So any question, any remark that you might have, please say it in the chat. Sorry, I will do my best to answer it. And whatever question or remark that comes to your mind, you can be sure that people watching the replay will also have them. So by saying them in the chat, you're giving a voice to the people watching the replay, which is always super nice. So that's enough of me talking. Let's actually get started. So I'm in Xcode and I'm going to create a new project. So I'm creating an iOS project. I'm picking the standard app template. I click on next. So I'm going to call this project Learning UIKit. And here, to create a UIKit project, what you want to do is, for the interface, you don't want to choose SwiftUI, you want to choose Storyboard. You will see just in a bit why it's called Storyboard and not UIKit directly. For the language, let's keep Swift. We are not going to go all the retro way, and also try to do it in Objective-C. Swift will be perfect. And let's just uncheck test because we are not going to cover this part today. All right, I need to put this somewhere. I'm just putting it on my desktop. Perfect. And so here we have a project that was created using UIKit. You can see that the UI is the same than with a SwiftUI project, in the sense that it's still an Xcode project. So we are still in a land that we somehow know, but we can see that the files that are part of this default template are quite different. With SwiftUI, you would have an app.swift file, a content view.swift file, and that would be it. And here you have an app delegate, a scene delegate, a view controller, this thing called main, this thing called launch screen. So that's quite a few differences. Let's go over them one by one. So the first file that we have is what's called the app delegate. So the app delegate, it's a concept that is very typical of UIKit. If you ask any iOS developer that worked with UIKit, they have worked with the app delegate at some point. And the app delegate in UIKit, it's kind of the equivalent of the app in SwiftUI, in the sense that it's the interface between iOS and your app. So you can see that this is where you find the entry point of your app. So this method, application did finish launching with option. So this is where you would write any kind of code that you would like to run once the app has started. Things, for instance, like initiating third-party services, like analytics, like bug reporting, these kind of things. And also, this is where you would implement other features, like for instance, if you want to monitor for memory warning, you would implement the method application did receive memory warning. If you want to monitor for remote notification, same thing, you will have a method application did receive remote notification, etc. All of the logic that is going to allow your app to talk with iOS would be here. Historically, the app delegate used to be quite bloated because since the app delegate is a singleton, is like a mandatory singleton, it would be very tempting to put a lot of state, a lot of singletons inside this big singleton. And so that's why you might have heard people joking about how the app delegate had become this very bloated type and this anti-pattern. However, originally, the job of the app delegate is simply to do this interface between iOS and your app. And so app delegate is the name of the class, and this class conforms to the protocol UI application delegate, where you find all of the methods that I've covered. Next, after the app delegate, you find the scene delegate. So the scene delegate, it's kind of equivalent of the scene in SwiftUI, which you pass, which you define inside your app.swift file in SwiftUI. So as you can see, the scene delegate is responsible for holding the window. And you can see that here we have a scene which is a window scene. This is the scene that you will use almost all of the time, I would say, for an iOS app, because an iOS app, very often, it has a single scene with a single window. Similar to the way that in SwiftUI, most iOS apps, they will have a single scene, which will be a single window group. So the idea is the same. The scene is one level below the app delegate, and it's responsible for managing, we could say, a group of windows together. In iOS, you will mostly have one scene. Might be a bit different on macOS, for instance, if you have a scene for the main UI and the scene for the preference panel, for instance. But I know macOS development way less, so I might be wrong on that one. And so here, in the scene delegate, for instance, it's when you will be able to monitor between when your window enters the background and enters the foreground. So same thing that you would be able to do on the scene in SwiftUI. We'll use the scene a little bit later in order to customize how the app will be at launch, in order to customize which view controller, and we'll see what it is just after, is presented at launch. Then if we move on to the next file is called the view controller. So the view controller can be a bit confusing when you come from SwiftUI, because in SwiftUI, you have only a single type to represent a view, and that type is conveniently called view. In UIKit, you will see, and we will see, that you have two types that represent the UI. You have UI view controller, but you also have UI view. And this can be confusing. So the first thing that's important to have in mind is that the view in SwiftUI is basically the equivalent of the view controller with a view. So what's the difference between a view controller and a view? A view is the role of a view is simply to take care of displaying some data on the UI. So you give it some data, it displays it on the UI using a label, using an image view, using a scroll view, whatever. And the job of a view controller is to own a view and to also take care of all of the presentation lifecycle. So the view controller, as you can see, is able to implement methods like viewDidLoad, which is called when the view has been loaded into memory, but also view will appear when the view will appear on the screen, view did appear once the view has appeared, view will disappear. So we have equivalents for this in SwiftUI. We have on appear and on disappear. that we call on a view. And you can see that in UIKit, it's split into two parts. The view controller owns the life cycle of the view, and the view simply owns how to display some data on the screen. So this can be a bit confusing, but once you start using it, you will probably get used to it quite quickly. Let me remove this code. I see a few messages in the chat. So Pixel Science is asking, you're going to need to explain the delegate pattern? Yes, it's going to come. I'm going to explain the delegate pattern in a few when I will show how a table view works. So if the app delegate seemed a bit confusing on what the delegate part means, it's normal. I will explain what a delegate is a little bit later with an example that is easier to understand than the app delegate itself. So we will go over this. Have you ever used Async Display Kit? No, never used this third-party framework in particular. All right, I think I've answered all of the questions. Let me move on to the next file called main. So this file called main can be confusing. So this is actually what's called a storyboard. If I try to rename it, it shows me the extension, so main.storyboard. So main.storyboard is one of the ways that you can define UI in UIKit. This is very different than SwiftUI, because in SwiftUI, your UI is defined as code, is defined in the body of a view. In UIKit, you have several ways to define the views of a view controller. You can either define the views programmatically, so by creating subviews, configuring them, we're going to see how we configure the layout, and then adding them as subview to a parent view. Or you can use a file like a storyboard file, which allows you to graphically, in a UI, drag and drop and position UI elements on your view controller. So this might seem nice at first glance, but this was also heavily criticized by developers, and I'm gonna show you why. To show you why, what I can do, I think here, I can show you how can I do it. I'm trying to open the file, yes, open as source code. So I'm opening the storyboard as source code, and you can see that under the hood, a storyboard is just one big XML file. And you can probably start to intuit what is the issue with this big file. It's the merge conflicts. When you are in a team, several people working on a storyboard, and two of you make changes at the same place in the storyboard, then you have the delicate pleasure of having to solve conflicts in the storyboard. So they tried to make it better as it went along. You can see that the tags are more descriptive. You can see that there are some comments to indicate where we are, but still dealing with merge conflicts here is not perfect. That's why several teams have made a choice of either not using storyboards at all or using one storyboard per view controller so as to reduce the chances of having a conflict, and when there is a conflict, reducing the severity of that conflict. So that's why storyboards, you can see some people being not big fans of them. To be honest, the app I was working on for the past 2 years, so Photoroom on iOS, it was using programmatic UI, so it wasn't using storyboards at all. But the app I worked on in the years before that, it was using storyboard, but with the rule of having one storyboard for each view controller, so as to minimize, as I was saying, the risk of merge conflicts. And honestly, it's okay to have one storyboard per view controller. You don't really lose a lot in terms of optimization. And yeah, if you've had the pleasure to deal with a conflict in storyboard, you definitely know what I mean by that. But we're going to build a simple UI in a storyboard just in a few. Then what else do we have? We have an asset catalog, but that's the same thing done for SwiftUI, so nothing else to say here. We have another storyboard, which is called the launch screen. So this storyboard allows you to implement what's shown during the splash screen. So when your app launches and is loading. So if you want to have like the logo of your app, for instance, this is where you would be implementing it. And finally, we have the info playlist, and you can see that there is only one thing in this playlist. It's the configuration that allows the app to know that it must load a storyboard called main as when the app starts. And you can see here, this little arrow indicates that this is the default view controller of the storyboard. So that was it for this kind of like lay of the land of what a UIKit project looks like. Now let's try to actually implement some features. So we're going to implement an API that I've been using and reusing times and again during my live stream, so the movie database API, because it's very simple to implement. It allows us to see quite a good amount of use cases, and it's also nice that it shows data about upcoming movies. So every time we use it, we see some new data. So it's kind of nice. It makes it feel a bit different every time I use it. So in order to implement this API, I'm going to copy and paste some code because the goal for this live stream is to focus on UIKit, and there is no interest in spending time implementing from scratch networking capabilities. So I'm going to create a few files. So first, I'm going to create a file I'm going to call utils. In these files, what am I going to put? I'm going to put two things. I'm going to put the API key I'm using to query the API, and a JSON decoder that has some key decoding strategy, so it's going to convert from snake case. This way we'll be able to reuse the decoder in all of our API calls. I see a few people in the chat who are joining. Thank you for joining, and thank you for the kind words in the chat. So we have this file called utils. Next, I'm going to add also a file to query some data about movies. So I'm going to call it movies service, and I'm going to copy paste some code. I'm going to explain it right now. So you can see I have some decodable struct called movie, which corresponds to what will be returned in the JSON. In the JSON, we will have a list of movies. And then to get the data, I make a network call, I decode the result, and I return it. You can see that I wrote this code a few years ago because it uses a completion handler. You could definitely also write it using async await. It wouldn't change anything, to be honest. I just copied this code because I already had it working in a UIKit app, so I was sure that it was going to work, but you could use async await here, absolutely no problem. So we have the movies service. Now it's time that we actually turn this blank view controller into a movies view controller. So first thing, we're going to rename it. What's interesting is that as I rename view controller, you can see that it's going to also change the name of the file, but you can see that it's also changing something in the storyboard. So we're going to have a look at it just after, but I wanted to show you this to let you know on the idea that a storyboard is linked to the source code, and when you make a change in the source code, if you don't reflect that change in the storyboard, you might break the storyboard at runtime. One more reason why some people are not fond of storyboards, because they can hide some nasty issues at runtime. So I've renamed my view controller movies view controller. All right. And I'm also having a look at the finished project. This way I can make sure that I don't make any mistake. So now let's go back to the storyboard. I need to implement a table view. I need to add a table view to this view controller. So what's a table view? A table view is the most basic UI component in UIKit to display a scrollable list of data. It was the first component to do this that was introduced. Fair warning, if you look at more recent UIKit examples, or if you need to implement an app using UIKit, you are probably better off using something called a collection view, which is a more modern and more powerful version of the table view. You have more options, especially around the layout. A collection view is much more powerful, but to learn how a generic UIKit component works, table view is better, I would say, because it's much simpler, and so we can focus more on how the communication between the different objects work. That's why I'm using a table view, but fair warning, in a modern UIKit app, I would recommend using a UI collection view instead of a UI table view. So let's add the table view and let's put it inside our storyboard, inside the view controller, inside the storyboard. Actually, you can see that here we have the view controller and then we have the view. So as I was saying, the UI is split into two parts, the view controller, which handles the lifecycle, and that owns a view in which you're going to add subviews. You can see that there is this notion of a safe area. So the safe area, you also have the same notion in SwiftUI. It's the part of the screen where it's safe to display content in the sense that it's safe because it's guaranteed the content will not be cut off. So the safe area differs depending on the kind of device that you have. For instance, if you have a device with a physical home button, the safe area will go all the way to the bottom of the screen. But if you have a device with no physical home button, then you have a safe area that is a little bit higher at the bottom because you don't want to display content that the user needs to interact with straight at the bottom because there is already this bar that the user needs to also be able to interact with. I see a few messages in the chat. Will this be recorded? Yes, it's recorded. A replay will be available as soon as it's finished and with the same link. So don't worry, replay available as always. Is there any case you might want to use table view instead of collection view in production? Honestly, today I would say use a collection view because with collection view, you have APIs to actually emulate the way that a table view works. So you have the same look and feel, and it gives you more versatility if you need to add more features as time goes by. So honestly, I would recommend going for a collection view and not a table view. Table view, I think, is great for teaching and for learning, but for production, I would recommend a collection view, honestly. Collection view with the table view compatibility mode, you get the exact same result on the UI. And if you want to add more collection view features in the future, then all of the groundwork has already been done. Are there advantages to using storyboards compared to strictly programmatic UI? There is nothing that you can do in storyboard that you couldn't do in programmatic UI. It's more a matter of preferences. I guess some developers who are more junior maybe prefer to be able to see the result because it makes it easier to reason about. I would say the programmatic UI, because it can be a mess quite fast, forces you to also encapsulate things more. But I've used both. I would say both work as long as you manage them in a smart way. But I would say teams who are more experienced tend to go with a fully programmatic approach because it gives you more control, and also pull requests are way easier to review when you have a programmatic UI than a storyboard. And that, for me, that might be the criterion that would make me argue that programmatic UI is better at scale than a storyboard. I would say even more if you have a remote team, because then it becomes like even harder. If people need to synchronize when there is a bad conflict, it can become messy really fast. So programmatic UI would be my preference because it makes code reviewing easier. All right. Trying to see if will I show programmatic UI as well? Maybe I will. I think I will try to show it. I will try to show it quickly so that you have an idea of what it looks like. Good remark. Thank you, because I wasn't thinking of doing it, but I will do it with this table view example actually. So I've drag and drop the table view, and I wanted to take all of the room that's available. So I'm going to put it like that. Actually, I wanted to cover the whole. Do I want it to cover the whole screen or just the safe area? No, I wanted to cover only the safe area. So I'm putting it so that it matches the safe area. And then I need to add something that's called constraints. So constraints, it can be one of the things that can be scary when you use UIKit for the first time, because we don't have this logic of constraint in SwiftUI. SwiftUI has the idea that every view is displayed from the center of the screen, and then you add padding, you add spacers, and there is no notion of constraint. UIKit is different. You need to constrain your view with respect to either the parent view or the browser view, so views that are higher in the view hierarchy or at the same level. Or maybe child views also. I'm not sure. I guess you can do it also. But basically, you need to constrain your view with respect to other views. What does it mean in this case? It means that we want to add constraint so that our view is constrained on the top, bottom, leading, and trailing edges. So here, constraint to the nearest neighbor, and in that case, the nearest neighbor is the safe area. So I've added the 4 constraints. We can go have a look at them, and you can see that indeed the trailing edge of my table view is constrained to be equal to the trailing edge of the safe area. So this can be quite confusing the first time that you use it, and that's kind of normal because what's happening actually is that constraints, they oh, we can see, oh, sorry, you couldn't see when I said the constraint. So sorry about that. I'm gonna move the window a bit. So I clicked here on this button here, which opened, let me do the constraints again. Thank you for letting me know. So I selected the table view, I clicked on this button here, and I chose to add constraints to the nearest neighbor, which is the safe area in that case, for the top, bottom, leading, and trailing edges. And I added the 4 constraints. And then you can see in the inspector, you can see that, for instance, the trailing edge of the table view is constrained to be equal to the trailing edge of the safe area. And by that, I mean the coordinates of the trailing edge of the table view is constrained to be equal to the coordinates of the trailing edge of the safe area. So what we are doing with constraints, actually, we are defining a system of equations, of linear equations, that will be solved at runtime in order to define the coordinates of each of the views in order to define what's called the frame of the view. So the frame of the view, be careful, it's a bit different than in SwiftUI. The frame of a view, it's its coordinate, where it is displayed on the screen, and a frame is composed of 4 values, the x and y, so the origin with its x and y coordinates, and the origin is the top left corner in iOS, and the size, which is the height and the width. And when you have these 4 coordinates, you have fully defined the space occupied by the view. So constraints, I won't go into too much detail about them because, as I was saying, you could spend hours talking about how they work. You can see that there are ways to customize them. For instance, I could say that I want a constant of -8, and if I do that, you can see that it adds a little space between the end of the table view and the end of the safe area. You can also add a multiplier that would allow you to say that one view's width should be equal to twice another view's width, for instance. So if you want to learn more about constraints, you will have no problem finding resources for it on the internet. That's why I just want to give you the basics of it, and we're going to use them a little bit more complex use case down the line. So yeah, indeed, constraints are confusing. UIKit has a lot of boilerplate. That's true. Compared to SwiftUI, there is a lot of boilerplate because basically UIKit is quite old. And one of the reasons why SwiftUI is able to get rid of most of the boilerplate is because SwiftUI builds on Swift, which is type safe. And on the other hand, this whole storyboard thing builds on more dynamic types being known at runtime, because that's how Objective-C used to work under the hood. And so you had to define much more boilerplate in order to basically specify what should happen at runtime. Whereas SwiftUI, because it has the type information, it's able to this boilerplate, in a way, it's kind of like hidden in SwiftUI because it can all be inferred thanks to the type and the declarative nature of SwiftUI. Well, that's a very good remark. And zip file in a multi-developer project and source control management is a nightmare. I agree. They made it a bit better when they gave, for instance, when there were like tags that were more descriptives, because zips used to be even worse at the beginning. But yeah, it can be indeed quite a nightmare. That's why I wouldn't recommend going with storyboards for a big project. Okay, so I've added my table view. Now I will need to have a way to reference my table view in my code. And the way we're going to do it is that I'm going to alt click, so option click on the view controller, and then I'm gonna want to create a property in my view controller, which refers to this table view that I've created in the storyboard. And the way you do it is that you hold the control key on the keyboard, and then you do what's called a control click. So you control click on the table view in the storyboard all the way to the source file. You let go, and you create what's called an outlet, an IB outlet, IB standing for Interface Builder, which was the original name of the UI to edit a storyboard back when it used to be a standalone app. And so we can give a name to this property. I'm going to call it table view and connect it. So now I have this property which is connected with my storyboard. Be careful if you were to rename this property without also making the change in the storyboard to say in the storyboard that here it's a different property, you would get a crash at runtime. So also one of the reasons why storyboards can be really tricky because of their dynamic, very dynamic nature. But this kind of a command click thing, when you come from the SwiftUI world, is the thing that shows you that you're not in Kansas anymore. It's very different. And at the beginning of iOS, Interface Builder used to be a separate app, and you would do this command click from Interface Builder to Xcode, and it would feel very magical that it would work. Like I discovered this after years of using Windows and seeing this work like out of the box. There was very much of a wow effect. I can tell you that. Okay, so now we have a way to refer to the table view inside our view controller. So we are almost ready to be able to display some data. Now we just need to have a way to fetch the data from the view controller using the Movies service. And for that, I'm going to introduce a view model. This way we can separate the code a bit, and it will be simpler to follow. And also it will allow me to introduce some kind of a simple architecture for an iOS app. So I'm creating this Movies view model, and I'm also going to create a new file that I'm gonna call variable, because I don't want to, oh, sorry, didn't mean to do that. I don't want to use Combine for this simple project, because Combine adds a lot of complexity, and if you're watching this and you don't know Combine, it's not great if I use Combine. So in order to have the view model and the view talk to each other in an asynchronous way, I'm introducing this very simple generic type called variable, which holds a value and also a closure that gets called whenever the value is updated. This way, my view model will expose variables that my view controller will listen to, and it will allow us to easily implement some communication between the view model and the view controller. So let's try and implement this view model. So I'm going to call it Movies view model, like that. What do I want to have? First, I want to have an instance of my service. So Movies service. Of course, in a real app with a good architecture, you would do dependency injection. You wouldn't hard code the creation of this dependency, but I'm doing it in order to simplify. By the way, if you want to see example of how to refactor a UIKit app to introduce a better architecture, I do have a live stream about it. It's using the same app than the one we are building right now. So I would recommend that you go check it out, because it will be a nice follow-up. So we need to have the Movies service, and then we need to have a way to communicate the movies to the view controller. So this is where we're going to have our variable, and it's going to be a variable that will hold an array of movies, and there will be an initial value which will be the empty array. So like that. And finally, we need a method that will fetch the data using the service. So I'm calling it fetch data, and this method will take the service, will call the method getMovie. It will get a result, and it's going to switch, not Swift, to switch over the result. And so in case we have a success, it's gonna do success.result. So actually, let me rename it to a response because it will be the network response. So I'm going to get the result, which is an array of movie, and I'm going to assign it to the value of my variables. And I'm just going to break for the error case. I'm not going to handle it. This way we can just focus on the happy path. And I just need to use weak self here. So like that. So we've implemented this very simple view model. I could have done it inside the view controller, but UIKit has been criticized a lot for naturally leading people to creating these massive view controllers where you have all of the logic. So I wanted to show you this minimal best practice of trying to put some of the logic outside of the view controller. So now we have a view model. We can use it inside the view controller. So let's also have our view model inside the view controller. So let's create it like that. And what we are going to do is that inside the method viewDidLoad, so what's called when the view controller is loaded into memory, first on the view model, we're going to set the onUpdate closure for the method, for the variable movies. So what happens when we get a new list of movies? What do we do in that case? So for now, it's gonna be a to-do. We're gonna have to implement it. And after we've defined the closure, we're going to call the method fetchData on the view controller. So now all we need is to actually display the data on the table view, because I'm going to launch the app actually. I'm going to launch the app just so that we can see what it looks like for now. So you can see we're displaying nothing. That's because the table view has no cell to display. Let me see in the chat question. If you did this class programmatically, would you create separate movies view or have UI call inside the movies view controller? For this simple use case, I would still keep the logic inside the view controller, because it's just there is only one view. So you don't need to create a movies view. But if you have a more complex UI, as we will see for the next screen we're going to implement, then I would recommend that you create indeed a movies view. It would be better. That's a great remark. And here I can get rid of the failure variable binding because I'm not using it. Okay, so how do you display data inside a table view? We're going to write a bit more boilerplate. Because to display data, a table view uses cells. It uses subclasses of a class called UI table view cell. So we're going to create a UI table view cell of our own. So for this, I'm going to create a new file, a new Swift file. I'm going to call it movie cell. I'm going to import UIKit. And I'm going to define a class called movie cell, which inherits from the parent class UI table view cell. And I'm going to give it two IB outlets. So this time I'm going to do the opposite, write them by hand and then do the link with the storyboard in the other way. We did from the storyboard to the source code. This time I'm doing it from the source code to the storyboard to show you that it works both ways. So I'm writing the code. So IB outlet weak var title label, which is a UI label. And same thing. So IB outlet weak var description overview, rather the overview of the movie overview label, which is also a UI label. So if you look into UIKit, you will see that there is actually that the default table view cell can handle displaying a title and subtitle, but I want to show you how to create a cell because it's really important in order to understand the logic of how a table view works. So now we need to create the cell inside the storyboard. So the way that we do it is that inside Xcode, we select the table view inside the storyboard. We go on the inspector, so this inspector right here, and we go into prototype cells and we increase this to 1. So if I can click on it, we increase it to 1. So we've created a prototype for a cell. So now we need to give that cell its class. You can see that by default it's a UI table view cell, but we want it to be a movie cell. So I'm making it a movie cell. Now it's going to reference the file we created in our source code. And so now I can start adding inside the movie cell, I can start adding the title label and the overview label. So the way I'm going to do it is that I'm going to use what's called a stack view. So a stack view is very similar to an H stack or a V stack in SwiftUI. It's what allows you to stack views in one direction, so either vertically or horizontally. And basically the stack view will take care of creating the constraint for you. So you can see a stack view as like a very simplified version of the SwiftUI logic in the UIKit world, because it's kind of like more declarative than your typical UIKit view, but still it's still quite more verbose than the H stack and the V stack in SwiftUI. So I'm taking a vertical stack view and I'm adding it. I'm gonna add it actually inside the content view of the movie cell. So the movie cell has this thing called a content view, which is the view inside which you're supposed to put your content. I won't go into detail of why you have the content view. You can find the details about it if you look at the documentation for UI table view cell, but the idea is that a table view cell can have many different states depending on whether it's highlighted, selected, this kind of thing. And so by putting your content into the content view, you leave a bit of room to the table view to handle the different states properly. So it's very important that you add your own content into the content view of the cell and not into the cell directly. So then I'm going to want to make the stack view to give it its constraint within the UI table view cell. And so I'm going to think I'm going to put it to pin it to the edges of the content view. So just like before, let me move Xcode so that you can see it. I click here and I select each of the edges and I'm going to put 0 every time. I'm going to add the 4 constraints. And you can see that it has put my stack view inside the content view. And it takes all the space of the content view. Actually, for the leading and trailing, I don't want to go all the way to the edge of the screen. I want to have some margin, and so I can define it in the constraint. So if I pick the constraint, which is the trailing constraint, for instance, I can do super view and relative to margin. And you can see that it added a bit of spacing at the end. And I'm going to do the same for the leading. It's going to be super view relative to margin. And so now if I look at the stack view, you can see that I have a bit of space for the margin. Just trying to see if I did it correctly. Yeah, trailing margin and leading margin. So normally it should be okay. We'll see if it's okay once I add my 2 labels inside the stack view. So I'm picking a first label and putting it inside the stack view. So actually, now we can see that it didn't put it correctly where I wanted. For some reason, it put it -20 when I actually wanted 20. When I was telling you that it can be confusing to deal with with constraints. So what I'm going to do actually is that I'm going to remove all of the constraints. I'm going to try and position my stack view. So it's like this. I'm trying to get just to get to move it. Can I just move it around? Yes, so it's here, and then trying to make it. You're supposed to have some handles to make it grow. Okay, just they don't appear the handle. That's great. So I'm trying to make it work. Okay, so now it's showing me the standard spacing, which means that it's going to take into account the default margin recommended by iOS. Okay, so seems to be better. Now I'm trying to put the label inside the stack view. Okay, so now the label is appearing with the margin taken into account. So let me see what kind of style I want to give to this label. So it's gonna be my title label, so I can give it the title value so that we can understand what it is when we look at the I'm gonna move it around. When we look at the storyboard, and I'm going to configure it. So this is similar to how we would do it in SwiftUI. I'm going to set here. I'm gonna set the bold system font, but you can choose also. I think there is a way to choose. Maybe you can do it programmatically, but to choose which type. Yes, you can choose here the text style. So if you want to put like title 1, title 2, headline, this kind of things. So here I have it, and it's and the font height is correct. So perfect. And now I can add a second UI label, so below. And this one is gonna be called overview. So I'm gonna call it overview. And finally, I can set some spacing between the two views. So in the stack view, I can say I want a spacing of 8 between the two views. And I have an error which says that I have no constraint. I need to give constraints to my label. So it seems I'm missing some constraints. It's interesting that I have these errors because I don't have this problem in my finished project. So that's weird because my stack view is fully constrained. So what's happening? What am I missing here? Maybe I didn't configure. Oh yes, it's this part right here. So distribution, it's on fill, but alignment. So I'm going to put it on leading to say I want to align on the leading edge. Axis vertical, distribution fill. Okay. I'm trying to understand what's missing here. Oh, I think it's because I need to say which of the two views should take precedence if there isn't enough space for the two of them. So let me check if this is indeed what I need to change. I think that might be the case. Yes, that's the case. So I need to say if there isn't enough space for the two views, which one should shrink actually. And the way you do it is, so here this content hugging priority, sorry, I'm going to make it slightly less a priority for the overview. This way, if there isn't enough space if there isn't enough space to displaying both, it's going to reduce the space of the overview. That's why I was saying that I'm not going to the details of how laying out views using constraint works, because you can easily spend 2 or 3 hours just to try and cover everything, and you will probably have missed things by trying to do so. So we are almost there. I think what I still need to do is to link these two UI elements to their counterpart in source code. So let me show my movies cell, and so I need to make the link, and so I'm going to make it by clicking the plus icon here and going all the way to the title here and all the way to the overview here. So we are getting there. I think there is just one more thing I need to do. I'm going to set something that is very important, and you will see why in just a few minutes. It's that the way it's going to work is that our table view is going to ask its data source for cells, and then a table view wants to try and recycle its cells, meaning that if there are 2,000 lines, the table view doesn't want to create 2,000 cells because it would just destroy the memory capacity. What it's going to do is that it's going to create enough cells to fill the screen, a few more to have a bit of advance when scrolling, and then as soon as the cell leaves the UI, it's going to be recycled, it's going to be reused in order to be able to be put back at the other end. So when a cell leaves the screen as the user is scrolling up, the cell leaves the screen, it gets recycled, and put back at the bottom. And actually, this is this trick that allowed the first iPhone to have very fluid scrolling, even on lists with thousands of items, even though the first iPhone didn't have a lot of memory or a lot of compute power compared to the iPhones that we have these days. And so in order for the table view to be able to recycle cells, it needs to know which cells are of the same kind. And it could use the class of the cell for this, but it uses something called the reuse identifier. This way, you have more control, and if you wanted, you could actually try and recycle cells of the same class, but in different ways. That's why you need to set this reuse identifier. I'm going to call it movie cell, so I'm going to call it the same than the type of the class in this case. And actually, you have some helper frameworks that generate this automatically by turning the name of the class into a string. But being able to set an arbitrary string gives you a lot of control over this recycling process, which was very useful, especially in the early days of iOS. So we are making progress. Now, all that we need to do is to actually allow the table view to retrieve its data. And the way that you do it is by implementing a protocol. So I'm going to create an extension of my class movies view controller. And I'm going to make it conform to the protocol UI table view data source. So it's the protocol that allows the table view to ask a third-party object for the data it needs to display. And if we take a look, this protocol, we're going to have methods which are going to be how many rows are there in the table view, and then giving the row corresponding for each section, and the row being displayed as a subclass of UI table view. So we need to implement the two methods. So I'm going to add the placeholders. The first one, so yeah, it asks me to implement self-forward index path, but before that, we need to implement also number of rows in section. So how do we know how many rows we need to display? Let me give a little bit more room to the code. How do we know how many rows we need to display? It's the number of movies we have to display. So we can just do return view model dot movies dot value dot count. Then how do we create a table view cell? That's where it gets a bit more complex because we need to implement this recycling mechanism. But you're gonna see that it's actually not that complex once you've wrapped your head around it. So the first thing we need is to get a cell. So you could be thinking, okay, let's create a movie cell. But if we do that, we're going to be creating a new cell every time. And remember, it's not what we want. We want to be able to recycle cells. So what we're gonna do is that we're going to ask the table view for a cell. And for this, we use the method dequeue reusable cell with identifier. And for index path. So what's the identifier? It's what we've just set in the storyboard. So it's the reuse identifier. So it's movie cell in that case. And then we pass the index path. And the way this code is gonna work, let me also split the code a bit so that you can see it better on the video, is that if there is a cell with this identifier being ready to be reused, it's going to return it. Otherwise, it will create a cell. So this way you will only create the minimal amount of cells that are needed. And you give this responsibility of knowing when you need to create a new cell or not to the table view, which makes sense because it's the job of the table view to display the data, to handle the scroll and everything. How did you split the code to new lines so quickly? So it's a shortcut, it's Control and M. Pretty cool shortcut. And if you want to watch after, I did last week a live stream called 65 tips to use Xcode like a pro, and it was one of the tips. So, and it's one that I find really nice. So it's Control and M. So let me write it so that you can see it. It's Control plus M, like that. So this is going to create the cell if needed, or reuse a cell otherwise. Then we need to have also the movie, so the piece of data that we're going to use to populate the cell. So let's also get it. So we get it from the view model. We access the array of movies and its value, and we're going to need to ask for an index. And an index on this array, we will get it through the index path. So on the index path, you have two values, section and row. Since we have only one section because we are in the default case, we can use row to know the number of the row. So it starts at 0, so you can use it to index the array. So we are making progress. Actually, I can at the end add the call to return the cell. Now all we need is to populate the cell actually. And so let me try and do it actually. So what I can do on my cell, I can do cell. So actually I can add a first cast to cast it as a movie cell. This way we'll have access to the properties that I've created. And so I can do title label.text equal movie.title and cell.overview label.text equal movie.overview. And here you can see one of the big difference between UIKit and SwiftUI is that SwiftUI is declarative. So you declare how your UI should look like. You declare what your UI should display. And UIKit is imperative. So you say the steps one by one and you say you take this cell and then you set this value to this property. So you really do the steps. Whereas in UIKit, you would describe what you want and then whereas in SwiftUI, you would describe what you want, and under the hood, at some point, SwiftUI has this kind of code, but it's all hidden from you. Actually, you know what? Actually, with I think that we've configured the cell. You know what? I'm looking at the finished project, but I think we've configured the cell. So we are almost there. We just need to actually let the table view know that the view controller is going to act as its data source. And the way you do it is that on the table view, you set the property data source and you set it to self, like that. You could also do it from the storyboard. You could say the table view in the storyboard and then here select the data source and say that the view controller is the data source. You can do both. I'm going to do it only in the code because it's a little bit more obvious and it makes it more explicit, so it's better for learning, but you could also do it in the storyboard. Once again, when you are able to write code in two places, it makes it harder to review the code. It makes how the code will run less predictable. So you can see, once again, one of the reasons why not everyone is super happy with using storyboards. We are almost there. I just need one last thing, is that when there is a new list of movies being set, I need to tell my table view to refresh its data, and you actually simply need to call the method reload data on the table view. And you need to use self because we're in a closure, so we need to use weak self right here. So let's see, it built successfully. So let's try and run the project, and we'll see if I've been able to make it work. That's nice. So that's pretty nice. We can see that there isn't enough space to display the overview in full. So let's see why we have this problem. I have an idea of why we have this problem. Yes, it's because if I go into my into my overview label. It's configured by default to display only one line of text, but I want to have at least 3 lines of text, so I've changed the value from 1 to 3. And if I launch my app again, this time you can see we have 3 lines of text. So the UI isn't perfect, but you can see that it does the job, it scrolls, and it scrolls in quite a nice way. You can see that it took us 1 hour to set everything. Of course, I did some explanation, but it took us 1 hour to set everything, and it took all of this boilerplate. So you can understand why people say that it's faster to prototype and create an app using SwiftUI. This is a great example of why UIKit takes longer to develop an app than SwiftUI does. But you can see that it works. I'm going to put it in dark mode. You can see that it works, and we have our data being displayed. Before we move on to implementing navigation to a detailed view, you can also see that, as I was saying, when you select, you have the selection state being handled for you by the table view. So I wanted to show you how to handle views programmatically. So if we want to deal with views programmatically, let's see how I can do it. I'm going to try and do it. What I'm going to do is that, because if I'm thinking that maybe I will do it a bit later, because I wanted to do it with the table view, but if I remove table view from the storyboard, I need to move all of the configuration away, and it's going to break things, and I don't want to do that right now. But I'm going to show it to you with the next view, because the next view we will display the detail of the movie, and so we'll have a header with a title and an image view, and so it's going to allow us to do this programmatic UI. First, let's try and put some order into the project. So I'm going to group the selection here into a folder called not movie, movies. Let me fix this like that. And also, because I'm going to want to implement a navigation, I'm gonna want to wrap my view controller here into what's called a navigation controller, a UI navigation controller. So it's the equivalent of navigation view or navigation stack in SwiftUI. And the way you do it in a storyboard is to do editor embed in navigation controller. And you can see it has put my view controller into a navigation controller. And actually, since I have this navigation controller, now what I can do, I think I can do it in the storyboard or in the code. I'm going to try and do it in the storyboard, is that here on the view controller, I can give it a title. So I'm going to call it like upcoming movies. And normally, I should see the title appear as the large title of the view controller. I never remember what you need to do to display the large title. So let's try and see first if it appears. Okay, we don't have the title appearing, so I've definitely missed something. So let me see what I might have missed. What did I miss? I'm looking at the finished code to see what I might have missed. Right. Oh, I think I need to do something on the navigation controller. So I need to say prefers large title. Can I do that here in the navigation bar, where I can say prefers large title? Shows navigation bar, yes. I'm sure it's possible to do it from here, but yes, here, navigation bar, and maybe it's here that I can do it. Prefers large title. Okay, so now we have room for the large title when nothing is pushed. So when we are on the root view controller. Okay, so we can see that we have the room for the large title here, and just the title, I must not have set it at the correct place. Where should I have put it? Trying to look at once again at the finished project to try and see. So the finished project does show upcoming movies. I'm just trying to see where I've set that value in the code. Oh, okay. So I see my mistake. I put the value here as the title of the controller, and actually I want to put it here in what's called the navigation item. And now you can see upcoming movies appearing. And so the navigation item is what allows a view controller to interact with the navigation controller that it might be embedded in. And so now if I relaunch upcoming movies, perfect. All right, we are going to implement a detailed movie view controller now, and we're going to implement navigation between the two. So first, I'm going to create a few things inside my project. So I'm going to create a new group called movie details, like that. Once again, I'm gonna paste in, copy paste some code because I don't want to spend too much time around implementing things like a service class. So I'm going to copy paste the code for something called movie details service. I'm going to create a new file like that, movie details service. So like that. So you can see in this file, we are, and I need to import UIKit because I'm using UI image. And so we have two methods, one to get the poster of the movie and one to get the credits. This way I will be able to display another table view in this details view. And now we are ready to implement a new view controller. So let me create a new Swift file. I'm going to call it movie details view controller, like that. Gonna import UIKit. Gonna create my class. So movie details view controller. I'm going to inherit UI view controller. And you know what? For this one, I'm gonna try. I was thinking, do I want to try and do the UI programmatically or not? I think I can probably do it. Yeah, I think I can probably do it. So I'm gonna try and do the UI programmatically for this one. So I won't be using a storyboard. So how would I do this? I'm going to declare my properties. So I'm going to have a first var, which will be, so what's useful to do is to do a lazy var. I'm going to call it poster image view. Is going to be a UI image view. And then the way you create it is that you do let image view equal UI image view, like that. You return the image view. And what's super tricky, and I did a full live stream about this a few weeks ago, is that whenever you create a view from code, almost always you want to set the property translate auto-resizing mask into constraints to false. It's false by default when you create your view from interface builder. It's true by default when you create your view programmatically, and it's almost never what you want. So you want to set it to false. For now, you can assume that it's a magic line. If you want to know in details why there is this line, which is there for compatibility reasons, you can watch my live stream about what does translate auto-resizing mask into constraints actually does. You also have an article on my website which sums it up. But it's important, otherwise your UI will not work if you don't have this. That's why I'm creating the lazy variable property with a closure to create it so that I can run this line of code when I create my view. So I want to have this poster image. I also want to have a title label, so I'm going to use the same structure. So title label, this one is gonna be a UI label, so like this, and here it will be title label, and let me rename it. if you write this kind of code often, you want to create a code snippet, a custom code snippet in Xcode to be able to automate it as much as possible. And for that also, I have a video on my channel, which is from something like two years ago. Actually, it's an old video from shot in my old apartment, but the content is still valid. So first, let's keep only these two views and try to display them on the UI and fill them on the UI. So just like before, we're going to create also a view model. So I'm going to create a new file. I'm gonna call it movie details view model. So this time I'm going to copy and paste the code because there is no point in me spending time to implement it. I didn't want to create a metal file. I made a mistake. So I'm going to create a new file, a Swift file, and it's going to be movie details view model like that. All right. So I'm pasting the code. Actually, I'm gonna just ignore the error because it's I'm not using it, and I prefer to explicitly ignore it than just like leave this property like unused. And so here also ignoring the error case like that. And so you can see the same logic. You need to give it a movie, and then using this movie, it's going to call get poster for movie and get credits for movie, and it's going to fill the two variables which we will be able to use in our code. So now let's actually create the view model inside the view controller. So we are going to create it like that. So view model is going to be a movie details view model like that. And actually, since we need, actually I can do even better since I'm not using interface builder. I can create the init I want for my view controller. So I'm going to create init with movie like that. And this way, because here this force and wrap isn't great. So I'm going to make it let movie like this, and I'm going to have an init like this where I can pass the movie. And this way here I will do, so this one will be a let. I'm just going to declare the type and not initialize it. At the same time that I declare it, and here I will do self.viewModel equal movie detail view model, and I pass the movie, and this way the code will be a bit safer. Unfortunately, when you use interface builder, you don't have control over the init because interface builder will probably call like init with coder in order to decode the storyboard, something like that, you can imagine. And so you don't have control over the init. You have a method that allows you to inject some dependencies that's been added a few years ago, but you have way less control. So it's one of the advantages of not using interface builder is that you have control over the init, and it makes dependency injection easier and also safer because you can have type safe in it. And since I'm not using a storyboard, I need to opt out officially by, and I need to call also super.init here. And I need to opt out by saying if you try to do init with coder, so by using a storyboard, you give a fatal error in that case. It's terrible. I don't remember how you init. Maybe it's this one. I don't remember what are the designated initializers of. So actually, I guess I'm supposed to do. I haven't implemented a view controller. Or maybe it's like that. No, it's not that. I never remember. Maybe you're supposed to mark it as a convenience init. Let property may not be initialized directly. Use self dot. So no, it doesn't work like that also. Didn't meant to do that. Oh, so it should be init with I should call super init. I don't have init with frame actually. That's why I'm a bit confused. Maybe I'm just going to use this one and just pass nil and nil. I don't know what's gonna happen. Okay, I need to do it before. Or maybe just that yes, I guess you're supposed to. Maybe it's just that you're supposed to. I think it was just that. Is that you're supposed to init all of the properties before you call super.init. That's I guess that was my mistake. We'll see if I was right or if I've forgotten something. That's the fun part of going off script. You never know. You're always gonna have this kind of small hiccups. Okay, we are almost there. Now what we need to do is to actually define the constraints, and we can do that, I guess, in viewDidLoad. So I'm gonna call super viewDidLoad, and then I'm going to define my constraints. So what I wanna do is to have on the top left, on the top leading, the poster, and then next to the poster, the overview of the movie. So actually, I call it title label. It was a mistake. It should be overview label. So something like that. So let's actually try and do it. So let's start by. So usually, what you do is that you create a method that you call setup UI like this, and you're going to call it inside viewDidLoad. This way you don't put all of your code in viewDidLoad. And so what I'm gonna do is to say, so self.view dot add subview. So I'm gonna add the first subview, which is the poster image view. I need to add it as a subview because since I'm not in interface builder, there is nothing in my QN code that says that this image view is a subview of the view of my view controller. So I need to do that. And then I need to define some constraints. And so the way you can do it programmatically is by doing nslayoutConstraint.activate and then define an array of constraints programmatically. And so you have some nice helpers called anchors to define constraints programmatically. So for instance, if I want to align the leading edge of the poster image view with the leading edge of the parent view, I can do poster image view dot leading anchor dot constraint equal to view, so self.view leading anchor, for instance. I can do it like that. Then I can do the same thing for the top anchor, so constraint equal to view.top anchor, like that. And I need to give it a height and a size in this case. And so let me see the value that I've chosen for these two constraints. It should be width 155. So poster image view dot width anchor, constraint equal to constant, in that case 155, and poster image view dot height anchor, constraint equal to constant, and this time 220. So I've defined a first set of constraints. So normally my image view should be displayed on screen correctly. I just need to give it some data to display. And for this, what I can do is that I can go on my view model. On the poster of the movie, I can say, okay, on update. So when I'm given a new poster image, what I can do is that I can update the value in the image view. So I can do self.poster image view dot image equal the poster image. And of course, let's not forget to call fetch data on the view model. So I'm gonna run. Oh, I hope. Oh, sorry. I might have hidden the code a bit as I was typing it. If that happened, let me see. Yeah, that might happen. Sorry about that. So now you have the code. So leading anchor constraint to the leading anchor of the parent view. Same thing for the top anchor, and absolute values, so constants for the width anchor and the height anchor. Let's run the code and let's see what's gonna happen. I can tell you nothing is gonna happen because I haven't implemented what's happening when I click on a movie. So I need to do that first. So let's try and do that actually. So this will be quite easy to do actually. The way you do it is that in the Movies View controller, just like we had implemented Table View Data Source, we will implement another protocol which is called Table View Delegate, which is used this one to monitor the interaction of the user with the table view. So Movies View controller is going to implement UI Table View Delegate this time, and it's going to implement a method in particular, which is did select row at index path. So let me split the code a bit, and also give as much room for the code. And what do I do when I select a row at an index path? We remove this. Well, first thing, I get the movie that corresponds to the index path. Then I'm going to create details, actually a movie details view controller. So I'm going to create my movie details view controller with a movie. So I give it the movie as an argument. And then I need to display it on screen. And the way that you can do it is that there are two ways to do it. Either on self, you can get the navigation controller, which is an optional, but that will be an optional that will be set. Let me show you. Yeah, it's an optional that will be set to a value when the current controller is embedded in a navigation controller, which is the case currently. So you can do that and then do push view controller, movie details view controller animated true. Let me split that code like this. Let's try and see if it works. Interesting. Oh, because I created a movies view model here, whereas I wanted a view controller and it's with movie. Made a mistake here. Nothing is happening. Why is nothing happening? If you've been following, you might have picked up on what I've forgotten. I've forgotten to let the table view know that it should use the view controller as its delegate. Same logic than for the table view. I set the delegate. And so at the beginning, we had this question of, am I going to explain the delegate pattern? Actually, we've used the delegate pattern twice because a data source is just a delegate with another name. The delegate pattern, it's a way that a highly generic component like a table view can ask a third-party object to handle some events or to provide it some data. So with the data source protocol, the table view is able to ask the view controller for the data it needs to display. And with the delegate protocol, the table view can ask the view controller to handle user events like the user tapping, selecting a given row in the table view. So that's the gist of it. And in terms of UIKit equivalent, I would say this is kind of equivalent to implementing a modifier like onSelect, for instance, having a onSelect. I don't know if there's a modifier called that in SwiftUI, but you get the idea. In SwiftUI, you could implement a modifier called onSelect and provide a closure that will be called whenever something has happened, or observe on change on a property that will be set whenever the user has done an action. It's the same kind of idea. So normally now, it should work. Okay, we have a crash. So here I called the wrong one. Fatal error, use of unimplemented initializer init name bundle. So actually, I'm gonna need to go on Google. I'm searching Google iOS programmatic UI view controller init. I'm looking for the answer on Stack Overflow. Let's see. Okay, so I think the mistake I made was that here I should have done this one. So init name and bundle set to nil. Yes. Okay. So we can see it's appearing. It's not appearing at the right place, but it's interesting that it's not appearing at the right place because we can see that it's not actually. It doesn't respect our view doesn't respect the safe area. That's the problem. But that's an interesting problem because you can see that it can allow me to show you what the issue was, and the issue was that I constrained my poster view directly to my view. But we saw when we looked at the storyboard before that this is not the right way to do it. You don't want to constrain to the view directly. You want to constrain to the safe area. And you can do the same thing when you lay out your view programmatically, actually. And the way that you do it is that you don't use the view directly, but you use the safe area layout guide. So you prefix with this, and this way, by doing this, so view.safe-area layout guide top anchor and leading anchor, normally the issue should be fixed. You can see that it's fixed. We have one problem, which is that it seems that the background color, let me put it back into light mode. The background color of the view isn't being set properly. So you can see that the animation is quite awful. But I think it's a problem of just, I think by default, in a storyboard, yes, it's probably that by default on a storyboard, the view has a background of white, and probably when you do it programmatically, it doesn't have a default background color. So let me do view. I'm writing cell just to make it clear that it's inside cell, but of course you don't need it. Background color, and I'm going to set it to white. Let's see if that was the issue. So it's better. It's a bit, I mean, it's a bit better. It's a bit better. The only thing is that now it doesn't respect dynamic. It's more like, I guess system background might be better. Okay, now it's better because it respects dark mode and light mode. You can see that the poster movie touches directly here the leading edge of the screen, which is maybe not what we want. So we can fix this by adding here a constant, actually. So I'm gonna split the call across several lines so that you can see it better. So actually I'm going to do it for all of them. This way it will be easier to read. And you can see I'm adding a constant of 8, which is the default margin on iOS, I think. And now you can see that we have a better margin. So we are good for this first view that we've laid out programmatically. Now let's do the same for the other one, for the overview label. And the overview label, I want to display it here. I want to display it next to between the poster and the trailing edge of the screen. So let's do that. So I'm doing self view, add subview, the overview label, and then I'm going to do the same thing with the constraint. So NSLayout constraint dot activate. And so here, what do I want to do? I want to say that the leading edge, so the overview label, its leading anchor, it should be equal to the trailing anchor of the poster image view, because we want it to be after it. So trailing anchor, and with a constant of 8. Let me split the call across several lines with a constant of 8, because I want to have 8 of spacing between the two of them. So what I say is that I want the leading edge of the overview label to be equal to the poster view trailing anchor plus 8 points on the screen. Then for the top anchor, I want to use the same one than for the poster image view. So the constraint will be equal to, this time, poster image view dot top anchor. Once again, splitting across several lines. Then we want to constrain towards the end of the screen. So I'm gonna say overview label dot trailing anchor constraint equal to, with a constant, you will see why. This time is going to be so view dot safe area layout guide dot trailing anchor, and I'm going to add a constraint of -8, because I also want a margin of 8, but since it's at the end this time, I want my overview label to end 8 points before the trailing anchor, hence the -8 this time. And for the height, let me see what I had set for the height. I'm gonna make it so that it doesn't go lower than the poster. So I'm going to use the same strategy than for the top anchor. Actually, it's gonna be overview label, bottom anchor, constraint equal to, and it's gonna be equal to poster image view dot bottom anchor, like that. So we are almost there to be able to display the label. We just need two things. First, we want to display as many lines as possible. So the way to do it is to say that the label is going to have a number of lines which is 0. And when you set it to 0, it means an infinite number of lines, or as many as possible. And of course, we need to also observe. I mean, we don't need to observe here because we already actually the overview, we already have it. So we don't need to do on update here. We can directly do overview label dot text equal view model dot movie dot overview, because we already have this data loaded. We don't need to wait asynchronously for a network call to return. So this way of setting everything, you can see that it's not the best architecture, because here some things are loaded asynchronously, others are loaded synchronously. Some things are set reactively, others are just set as a one shot, and then if the value is updated, it wouldn't be updated, even though movie is a let constant, so it's not possible for it to change. So you can see it's not the best architecture, but at least it does the job. And now, if I click, you can see that we do have the overview of the movie being displayed. And what's interesting is that you can see that it's being centered because I've given two constraints saying that I've given two constraints that give the same importance to the top and the bottom anchor. So if I wanted to make it stick to the top rather than the bottom, the way I could say it is that instead of saying that the bottom anchor should be equal to, because if I say equal to, then it's going to take this entire space for the frame, and then the text is going to display centered inside this. So maybe there is a way to display the text rather to vertically align it at the top. Let me see, actually. Maybe there is a way to do it. I'm just trying to see if there is one. No, this one is for left, center, and right. So maybe there is a way to implement the vertical alignment in another way, but a way to say that we would like to stay pinned at the top and then take as much space needed downwards, but never exceeding the height of the poster, is here, instead of saying equal to, it's to say less than or equal to. So the bottom anchor should be less than or equal to the poster image view bottom, but never more. So here you have less than or equal to. So you can also have inequalities when you define a constraint. And if I look, now it's better. Now we have a UI that makes more sense. So it's getting there. One thing I would like to do is here you can see that when we go back, it's still selected and it's not the best UI. So actually, it's quite easy to implement the deselection. If you're following the replay, you might want to pause and try to do it yourself, because I've given you all of the building blocks to do it. I'm not going to take a pause of 10 minutes if for the people watching live, so I'm going to do it right now. But I would really recommend you give a try to doing it yourself. And the way to do it is through the delegate. We have a method that is called... so we have did... I'm looking at select, actually. Actually, no, you don't do it by implementing did deselect, because it's not a deselection. What we want to do is that after we've pushed the view controller, we want to deselect. So we want to do so table view dot deselect row at index path animated true, like that. And this way, when we come back, you can see that it's no longer selected. So depending on your UI and your UX, you might want to implement it that way. You might want to keep the last selection selected. There are apps, I think the mail app might behave like that, because user might want to go again to see the last thing that they've looked at, and they want to know which was the last thing they've looked at. You could also do the deselection when you come back to the screen. So I want to show you how you would do the deselection when you come back to the screen, because it's an interesting case. And I think the way you would do it would be by implementing view did appear. So the method that's called when the view has appeared. So it's called when it appears the first time, but also if you navigate to another view and then come back, it's going to get called again. And I think what you could do is that on the table view, you have a property which is called select. I think there is a property that holds the selected row. Is there one or not? Yes, you have something called index path for selected row. And you could do if let selected row index path. So it's a bit of a mouthful, equal table view dot index path for selected row. Then in that case, you want to do table view dot deselect row at selected row index path animated true. And if you run the code again, normally it should select. And when you come back, it nicely deselects, which might be a better UX. You can see that it does it a little bit later after, it waits for the view to have been fully displayed before it starts the animation. So maybe you might want to actually try the code in view will appear instead. So let's try and see what it does. So you can see it happens a little bit earlier, so it might feel a little bit more dynamic, while also conveying the info of what you had selected before. So it's really like, it depends on your UX. I just wanted to show you how it works, and because it's also a nice way to show the other method of the life cycle of a view controller. So we saw view did load a lot, but you also have view will appear, view did appear, view will disappear, view did disappear, etc. I'm going to remove this line, which is no longer useful. All right, what do we have next? I think last thing I wanted to show is how to add another table view. Actually, in the details, we need to have a table view to display the credits. So let's try and implement this table view. So I'm going to have the same strategy. So I'm going to create here lazy var credits table view. So UI table view. If you're watching the replay, same thing, you might want to try and implement it yourself, because it's quite a good exercise, and by now you should have all of the building blocks to do it. So like that, return create table view. So we already know that at some point we're going to need to implement the protocol protocol UI table view data source. So movie details view controller is going to implement UI table view data source. And we'll need to implement number of rows in section and cell for row at index path. Let me split the calls so that we get something that's more readable. So what can I do here? I can, at this point, set here at this point, I can set the data source, which is going to be myself, like that. And I can implement the two methods. So what are the numbers of section in the credits list? Well, you take the view model, you take the cast, you take the value, and you take the count. The return is implicit for one-liner function. I'm just going to write it out so that it's very clear what's happening here. And here to create the cell. So how should I do it? This time I'm going to do it a bit differently. We'll see if it's gonna work, because I'm not using a storyboard this time. So I guess what I want to do I think I'm gonna need to do, I'm going to do two things. I'm gonna use just a classic UI table view cell, but I will need to still set the reuse identifier. So I think the way I can do it is by doing credits table view register, and you can register, normally you can register a class. How do you do it? No, it's when you want to register just like a xib, but I'm not gonna do that in this case. I'm gonna do it another way. So I need to have my cell. So I'm gonna have my cell by doing table view dq reusable cell for index path. And so here my ID will be movie cast. And the index path is just the one I'm given as an argument. So I haven't set it anywhere. I'll try and see where to set it so that views are being reused, because right now it might create a new cell each time. So actually on the cell, I'm going to just set the reuse identifier to be movie cast, just so that this way if a new cell has been created, this is going to be set. I'm not sure it's the best practice, to be honest. I'm improvising to do this code programmatically, but no, it's, you cannot write it as get only. Okay, so it's not gonna work. We should still be able to configure the text on the cell. So on a cell, if you look at it, you will see that there are properties called text label and details text label, but they are deprecated, and you're better to use something that's called a list configuration. So I'm going to copy and paste the code because you will see it's quite a bit of boilerplate. But what you're doing is that you're creating a cell configuration. Just forgot to do one thing, is to get the data about the cast member from the view model. So same strategy than for the movie. Cast value, and then we subscript for indexPath.row. So we get the cell, we get the default content configuration, and it allows you to declaratively declare what you want to display on the cell. So you can do content.text is the text will be castmember.name. The properties of the text will be headline style, and same thing for the secondary text. And then we set the content configuration back on the cell. So it's a better, it's a more modern way. And anyway, the other properties, the old ones, so cell.text label are deprecated, so it's better to use this. But as you can see, it's a bit more code. So that's why I didn't try to remember it by head, because I wouldn't, by memory, I wouldn't remember this. And actually, I might want to just return the cell at this point. The reuse might not be very well implemented here. I'm not sure, to be honest. So don't necessarily reuse this code as is in production. But at least it shows how it should work, how the structure should work. What else do we need to do? We need to say that whenever on the view model the cast changes, then we want to reload data on the table view. So we want to refresh the data in the table view. So let's do that. So self table, I think it's called cast. How is it called? It's called credits table view dot reload data. So that's done. And one last thing we need to do is to actually lay out the table view. So same thing, self dot view add subview cast. No, it's credits table view, and then we add the constraints. And so we're gonna want to display it below the poster and the overview, and all the way to the bottom. You might think that this is not the best UX when we'll start scrolling, and yes, indeed, and then we will be fixing it. But I want to show you the whole walkthrough so that you know how to do it yourself if you need to. So let's put the table view, so the credits table view, let's put it below the poster. So its top anchor should have a constraint equal to the bottom of the poster and with a constant of 8. So I want 8 points between the two views. Then for the leading anchor, I want to constrain it to be equal to view dot safe area layout guide leading anchor. It's gonna be the same thing for the trailing anchor. So constraint equal to view dot safe area layout guide dot trailing anchor. So like that. And for the bottom, it's gonna be the same thing. I'm gonna do it with respect to the view safe area layout guide and for the bottom anchor. So this code here is quite monotonous to write actually. Bottom anchor. By the way, if you write UI programmatically, it's better to always pick the same way to go about. So you can see sometimes I did like leading top trailing bottom, sometimes top leading trailing bottom. It's better to always do it the same way. Either you do leading top trailing bottom or you do top leading trailing bottom, but you pick one way and you stick to it. Otherwise, it's going to become messy quite fast. So don't do what I've done. But normally, now, if I click, oh, we have a crash. What did I mess up? Unable to dequeue a cell with the identifier movie cast. So indeed, I haven't registered a nib or a class. So I need to register a class. That's what I wanted to do and I couldn't find the method. So when I create my table view, I need to tell it, okay, when you are asked to dequeue a cell of type movie cast and you don't know, and you don't already have one, how do you create it? We didn't need to do it when you created when you used the storyboard, because in the storyboard, we used, in the storyboard here, we use prototype cells, and prototype cells, they are implicitly registered with the table view. But here, since we are doing everything manually, we need to register manually the cell with the table view. And the way to do it, so we have register, and you can see here you have register a nib. So a nib, it's when you are using a zip file, which is just like a storyboard, but only holds one view. They're not used a lot, zip, but they're still used when you want to define a cell in a UI file. And me, I want to register a class actually. And I'm trying to see how to do it. So I think I'm also going to go on Google. I'm going to do iOS UI table view register class for reuse identifier. How are you supposed to do that? Oh, okay, so you do have a method register. Why? It's not suggesting. You see, I have the method with UI nib, but me, I want one which is like register a class for cell reuse identifier. But why is it not working? I'm going to try to write the code that I'm seeing in the suggestion. So it's register. Oh, you do have it, and you can pass a class. So I don't know why it wasn't suggesting it, but this way I can pass a class. So here is just UI table view cell.self. So I'm just passing the basic UI table view cell class, and I'm going to pass this ID. So of course you would want to create a constant. You don't want to copy paste the code, but here I'm doing it just because it's a little bit faster. And normally now everything should be working correctly. Yes, you can see now it's working correctly. We can scroll here. Everything is working pretty nice. You can notice this empty space here, which is because I think it's room for the large title, which we are not displaying. So we want to display a large title, which will be the title of the movie. And so the way we can do it, it's in view did load. Actually, we can do it in setup UI. We can do it just at the same place than we had set up the background view color, and we can do something like, so we saw it's on the navigation item. So navigation item, and then it should be the title, and the title will be viewModel.movie.title. let's see if it was indeed the right property to set. Yes. Now we have a view that arguably looks better. So that's pretty nice, actually. That's pretty cool. We have the cast. We can see there are lots of characters in Dune 2, and I went to see it on Saturday, so I can confirm there are lots of characters in that movie. But you can see one thing that's a bit annoying is that, I mean, it's a UX point of view, but when I scroll, the scroll is happening in a small portion of the screen. You might want to scroll and to scroll everything, and so that the poster and the overview would go like out of the way when you scroll. Turns out that you can do this in UIKit, and you can do it by putting the view that you want to scroll away in the header of the table view. And so we're going to try and put the poster and the overview label in a view of their own, which we will then move into the header of the table view. So let's create this header. So I'm going to call it header view. So it's going to be a basic UI view. I'm going to follow the same logic than before. So I'm going to do let view equal UI view, view.translate auto-resizing mask to constraint set to false, and then return the view. And so inside set UI, what I'm going to do is that actually I will add the poster image view to the header view. And so every place I was using the view, I'm going to use the header view instead. Same thing here for the overview label. So everywhere I was using the view, I use the header view instead. And now I'm going to put the header view. I'm going to put it, this header view, I'm going to put it as a header of the table view. So credits table view, and then there is something called table header view, and it's going to be my header view. Let's see if it's gonna work. I think I made a mistake somewhere because nothing is appearing anymore. Oh, I think I made a mistake because, yes, because I didn't update the layout of the table view, which it lays out relatively to the poster, which is into its header. So it has no way of being laid out correctly. So actually, I just need, it's almost there, the code. I just need to lay out the top anchor that must be the top anchor of the safe area, and I can remove the constant. I don't need the constant anymore. Now it works. I mean, there are a few issues, but it works mostly. And you can see that as I scroll, everything now scrolls with it. So it's much better. There is just one tiny bit of a problem, I think. So the overview label, I said its trailing anchor should be the trailing anchor of the header view. And I think the header view, maybe here I don't want to use the safe area layout guide actually. No, that was not the issue. Oh, I think the problem is that I need to give constraints on width and height, at least on a height constraint for the header view, because otherwise it doesn't know which size it should have. Yeah, I think I need to give. So I'm going to do it like that. Activate. So it would be something like header view dot height anchor constraint equal to constant, and I'm going to put it like, I'm just putting a hard-coded value, which is the height of the poster plus 10 to leave some room. Let's see what this does. Okay, that's a bit better, and there is just the width, which is still not constrained. And how can I constrain the width of the header view? Actually, its width anchor, it should be equal to so equal to I don't want the multiplier, I want to get rid of it. It should be equal to I guess it's the credits table view width anchor. I want to have the same width than the table view. Yep, that's what I wanted. And so now you can see that it scrolls, everything scrolls together, and that's arguably better from a UX point of view. So I've showed you almost everything I wanted to show you. I think now you have a nice overview of how a UI Kit project looks like. One last thing I wanted to show you to finish is how to customize the launch of the app, because now everything is happening automatically. It's taking this main storyboard and it's putting the initial view controller in the window and everything. But if you want to try and have more control and do everything by hand, you can. So what we're gonna do is that actually I'm going to get rid of the navigation controller right here. You can see that now I've also lost the fact that this scene is no longer the initial view controller, but that's no longer a problem because we are not going to use like the automatic init of the storyboard. So what I'm going to do is that here I'm going to remove the entry that gives the storyboard name to the app. So now the app has no way of automatically starting with the storyboard, and instead I'm going to write myself here the code in order to programmatically create the navigation controller and set everything together, just so that you can see what it looks like. So I'm going to need to interact with the scene, so I'm going to need to give it a name this time so that I can interact with it. I'm gonna give as much room as possible to the code. And so first thing I will need to do is to create the window. The window is the top level object which holds all of the view controller and all of the views. So I'm going to create a window, so no, a UI window. I need to give it a window scene. So I'm going to give it the window scene I've been given, the window scene that the scene delegate has just responded to. So I'm giving it the window scene. Then what do I want to do? I want to programmatically create a navigation controller. So I do it by instantiating a UI navigation controller. Then I'm going to configure it a bit. For instance, I'm going to say that the navigation bar prefers to display large title, just to show you that what you can do in Storyboard, you can also do it in code. And then now I need to create the initial view controller, which is a movies view controller. So how can I do it? Because it's happening inside my storyboard. So what I need to do is to get a reference to my storyboard. So you do it by doing storyboard named, and then you give it the name and the bundle that it's in. So the name is main, and the bundle, since it's the main bundle, I can just pass nil here. And then we're going to call not instantiate initial view controller, because I've removed this because I want to show you the full process, but instantiate view controller with identifier. So I'm going to need to create an identifier here. No, where do you set the identifier? You set it so many places to set it that you forget, actually. Where do you set it? You set it here. So in this inspector here, you have storyboard ID, and so I'm going to call it movies VC, for instance, and that's what I can use in my scene delegate in order to create the view controller from the storyboard. Be careful, this returns a non-optional view controller, but that's because if you pass in an ID that doesn't exist in the storyboard, it's just going to crash. So be careful when you use this method. And then what you can do is that on the navigation controller, you can set its array of view controllers, which will just be the movies view controller. It could have been done differently. You could also have done navigation controller, push view controller, animated false. You could have also created actually the navigation, actually that might have been even better to create the controller and give it a root view controller. It would have been better actually. You know what? Let me take this code that was above and move it down a bit. I tried to create it from the outmost controller to the innermost, but it's better if you create the innermost first, because this way then when you create the UI navigation controller, you can just give it a root view controller, which will be the inner view controller. So this way, it's the code is a little bit nicer. And then you can just, on your window, you can set as the root view controller, so the parent view controller that the window displays, you can set your navigation controller. And finally, on the window, you call a method called make key and visible, which makes it the main window, the one that has the focus, and makes it visible. And now, when I launch the app, normally, if I don't make any mistake, you can see that the app is still working as it should. But now I have programmatic control over how the app is starting. By the way, I'm noticing I forgot one thing. I forgot to add the little disclosure indicator that lets you know that you can tap on the cell. That's way better for the user to have this. So actually, it's very easy to set. It's a property of UI table view cell. So here on the movie cell inside the storyboard, you would open the inspector and do accessory disclosure indicator like that. You could also set it programmatically when in a cell forward index path, of course. And now we can see we have the nice disclosure indicator and the code, the app looks a little bit nicer thanks to this disclosure indicator. And I think I've covered everything I wanted to cover. I wanted to last 2 hours. It's been 2 hours. Perfect timing. That's great. So I guess that's all for this live stream. I hope you've enjoyed it. I will put the code that we have written on GitHub. You already have the link to the repo in the description so that you can check it out if you want. Thank you to those who assisted to the live stream, who asked questions, who made good remarks in the chat. There were things that I wasn't thinking of showing, and because you mentioned it, I showed them, and I'm very glad that you did, because I think that showing them really did improve the quality of the content I've shown. So I hope that this live stream managed to fulfill its promise, which was to give an introduction, what I would like to call an actionable introduction to UIKit, in the sense that having seen this, now if you need to work on a UIKit project, you should have some bearings and you should be able to know where you need to look when you need or you want to learn more. But I think in these 2 hours, I've covered a lot of ground, as much ground as it was possible. So I see a few nice messages in the chat. So thank you. I'm glad to hear that you've enjoyed it. If you have some colleagues that could benefit from this live stream, please share the link with them. As I said, there will be a replay available as soon as the live is finished with the same link. So I think I just have to say, as always, thank you for watching. Thank you for interacting in the chat. And see you next time for another live stream or another video. Bye-bye.